Hi everybody, my name is Mtwana, and hey, I'm back again after for a long time. I'm back again. Look, if you FaceTime to this program, please leave a comment. It's very important for you to leave a comment so I know if this video is helpful for your program or whatever you're doing. Leave a comment, like the video, share with your friend. Without further ado, let's get started. So we have a two question here. So in exam, when they give this question, they're not going to tell you this is separation of the variable or this is this type of question. So it's very important for you to do a lot of this type of questions so you get used to when just by looking at it, oh, this separation of the variable, oh, this I have to use integration factor, or this homogeneous, or this first order, this is second order. So I'm going to show you all of that. Okay, now let's start with this. So this one, whenever you have this type of question, for the most case is separation of the variable. I'll show you how to do it. So we have a 1, 2. Let me start with the question number 2. But hey, I forgot something. For the question number 2, they say, for the question number 2, they say here, value of x, whereby x, sorry, I forgot, x equal to 0, and y equal to -2. So they give you initial value. So you know what? If I can do question number 2, the question number 1 is going to be way easy. Two different questions, but you understand question number 2, question 1 is going to be way easy. Now, let me show you how to do question number 2. So let's separate the variable. It means y has to be y, x must be x separate. So I'm going to take this over. So I'm going to be left with 2x, y plus 1, dx equal to y dy. And the next things, I don't need this. This y should come here to y. So here I'm going to be left with 2x dx equal to y, and this is going to come under, because I divided y plus 1 is going to be y plus 1, and then here we have a y over y plus 1, and then dy. So what we're going to do now, for the most of the time I like to write y on the left. So I'm going to write my y, and then here I'm going to say y plus 1, and then here it's going to be dy equal to 2x dx. You understand? So what I want to do here, I have to integrate throughout. So I have to integrate on the left and integrate on the right. So here on the left, what I will do, I will let, because this is just a normal integral right here. But I want to let, let's say t, or any value, t equal to y plus 1. And then I know for facts, this can be equal to t, but let's make something y, because here I have to get y. What is y? Y equal to t minus 1. T minus 1. But also, when you differentiate, it's going to be dt equal to, differentiate y is going to be dy. So what I'm going to do, I'll substitute all these values here into on the left hand side. So then here, I'm going to say my integral. Instead of y, I'm going to say what the value of y equal to t plus 1, t minus 1. So what, t minus 1, and here over y plus 1 equal to t, and then dy equal to dt. And then here, this side, we still have our 2x dx, or you can integrate if you want, and then you say this equal to 2, and then integral. When you integrate x, some people want to go slow, but you can simply integrate x dx. It's going to be, when you choose going to come back, it's going to be x2 x squared over 2 from the power rule of integration, okay? And then we plus our c, but we have to come and do something over here. So you can simply integrate straight away, and this is going to give you t minus ln of t, but whenever you have a ln of right absolute, 2 and 2 cancel, is going to be x squared plus c. Some people may say, how did you get this? Let me explain to you slowly. Now, I just forgot, like I'm dealing with a student right now. Okay, so now I'm going to say, let me just show you how this comes about, step by step. Some people don't know why this comes about that. Okay, look, I can say integral, and then t over t. So t over t equal to 1, and minus 1 over t, and then dt. So integral for 1 dt is going to give you, look, integral for 1 dt equal to t. So that's why I say this equal to t. And then when you integrate 1 over t, it's equal to ln of t. So let's say t minus ln of t. That's how it came. Okay? So for some people say, how did that come about? How did you get that? Okay, that's how it came. So now we say this equal to x squared plus c. But remember in the equation, they didn't give us t. They give us x and y. So we have to replace that. What's the value of t? T equal to y plus 1. So that's going to be y plus 1 minus ln. But whenever you have anything in front of ln, put your absolute. T is y plus 1. And then equal to x squared plus c. So now, we know the value of y. They give us initial value of y. What the initial value of y? The initial value of y, x equal to 0, y equal to negative 2. So it's going to be negative 2 plus 1. What is negative 2 plus 1? So say negative 2 plus 1 will not equal to negative 1. But you want to show the steps if you want. Now we say absolute. Negative 2 plus 1. Or you can simply say negative 1. But hey, just play for funny. X equal to 0, so it's going to be 0 squared plus c. So now, negative 2 plus 1 equal to negative 1. Negative 1 minus ln absolute. Negative 2 plus 1 equal to negative 1 and then equal to c. So we know the value of c. So that's a value of c right here. So all these, we're going to come and substitute in this equation here. Main equation. Because we didn't have a c. Okay? We have to substitute right there. So then we're going to have, instead of saying this will be y plus 1, and then minus, let me make sure if it's record because sometimes it doesn't record. Okay, perfect, and then minus, and then ln, say y, plus 1, and then equal to x squared, is x squared, and then plus c. What is a c? I was equal to negative 1, so say negative 1, okay, minus, ln of negative 1, and then, okay, we're done already. My apologies. So negative 1, okay. So then, what we're going to do now, I can simply say, I can take this one over here. So positive 1 coming is going to be negative 1, so it's going to be negative 2. So I can simply say finally, I had a space here. Let me see if the space is enough to write. Yeah, I can write right there. So I can simply say, y, 1 take over, minus ln of y plus 1, and then equal to x squared plus 1 minus 1. Here is plus 1. Minus 1 is going to be minus 2. So I can write this and then minus 2 after. So I can say ln of negative 1 and then minus 2. And this is going to be our final answer for the first question. Okay? So that's the first question. Now, let's go for the second question. So the second question is way easy. Okay, the second question is way easy. Let me show you how to solve it. Oh, apologies, I'm not supposed to raise that. So I can simply do this in I can do 1 minute because you understand a lot of concepts now. Or less than 1 minute. So I'll just separate the variable. So separating the variable is easy, so I'm going to say this is y and y must be on y side. So here I'm going to be left, okay. I copied the question wrong, apology. Okay, this is x here, this is x. My apologies, I'm sorry, okay. So what I'm going to do, x must be x and y must be y. So I'm going to say this must be here y minus 3 dy, and this is going to be 4, just a 4. Dx is dx, and then divided by x. So you divide by x this side. Divided by x, so it's going to be 4 dx over x, and then divided by y means it's going to be over y. So for now, do not use that methodology. The reason why I use that methodology, because at face, look here, let me explain something. So what I'm going to do, integrate and integrate. So this is easy because I can simply say integral of y over y, integral 3 over y. But for the first one, it was integral y minus 1. Can you see? That's why we have to let this equal to t. Or any value, let's say m or any value. But for now, I don't have to do that. See? So now I'm going to say integral of y over y equal to 1 dy minus 3 over y, and then dy also you integrate. Because integrate the first group, integrate the first group, integrate the second group. Okay, minus in between. So this is equal to 4 goes behind, integral 1 over x dx. And then we say, when you integrate y, you're going to get y dy equal to y, and there's going to be 3 ln of y. Absolute, whenever you have a ln, make sure you put your absolute. And this is going to be 4 ln of x absolute, and then plus c. And the equation is over. But look, I'm not going to leave my answer like that. What I'm going to do, I'll take c to the left, and I'll take this over. So I'm going to say y Or I can just simply take right here, equal to, look, ln of x absolute, this is going to be plus 3 ln of y, and then plus c. So what I want to do here, this is for my apology. I'll take this 4 back, because look, if you have a, let's say a ln of t, you can simply say ln of t power a, means I can take this back. So I can say y equal to ln of x power 4, come here, and the plus ln of y power 3 plus c. So we have a long rule. Long rule say if somebody give a ln of a plus ln of b, this may say ln of a times b. This is long rule or logarithm rule. But if it's division, let somebody say ln of a, oh man, ln of a minus ln of b, this may say ln of a over b. So for now it's plus, means I'm going to take these and these, I'll multiply them together because there's a plus. Take whatever you have here, put them together. So this is going to be y ln x power 4 times y cubed. So x power 4 y cubed bracket plus c. So this is going to be the final answer. Or if you don't want to write like this, you can simply write, this is the final answer. And it's correct. But if you don't want to write like this, you can say y minus c equal to ln x power 4 y power cube, yeah, or you can write like this as the 2. So look, like I say, if you FaceTime in this program, right, please leave a comment as a feedback so I know, oh, there are people watching my video, there are people, just let me know where you're coming from. If the video, man, just give me any feedback, man, in comments. I appreciate it. For that being said, thanks a lot for your time. I'm gonna see you soon. Peace, and I'm out. Bye-bye.